This is the example code for writing to an electronic product code tag, so the RFID can recognize the toppings. So first I had to go through each of the toppings and write to the tags. This is the code that does that. It's based off some sample code that's from the SparkFun Electronics library, but has been extended slightly. So first we just include the libraries, we define the receiving and transmitting pins on the software, so as to where the serial data will be received and transmitted from. I begin serial communication at this baud rate, then flash the LED pin on for a second just to initialize so that I'm aware that the system has been turned on. Then wait for the serial window to be opened, and then print initializing, and then we try and set up the nano module at this baud rate. So down here, so it takes a baud rate and sets the nano up. Tries to begin both the software communication and the module itself, and waits for that serial communication to begin. It then starts to read and checks that everything's working fine. If not, it'll print for the user to understand why it's not working, and else it'll try and change the baud rate so it will work, and eventually hopefully we'll come to return an all good message, and if not we'll return false if there's some issue, otherwise we'll return true. So returning up, so here that sets up the nano, and if it's equal to false, it'll print for the user so that the user understands that something's gone wrong. Otherwise, it'll continue on, set the region so that it can know which frequencies to transmit at, set the read and write power for the module, and then enter the loop. Once within the loop, it'll print this to prompt the user to get all the tags out of the area apart from the tags they want to be written. We'll wait again for the serial port to be ready, wait for an input from the serial, so just any key from the user. This string was changed several times as I added different toppings to the pizza. So sometimes this was red pepper, green pepper, etc. Although always making sure that it was an even number of characters in the string, and that it was no longer than 12 bytes. So here 1, 2, 3, 4, 5, 6 is even. So all of these bytes will be successfully added to the tag. Then this function calls the module and asks it to write to the tag, and then takes a note of the response type. If it's successful, my LED blinks and the serial says yes, it's been written, and otherwise it'll tell you that there's a failed write and some explanation of why. So that is what this code does, just constantly looks for serial input and then writes to the tag. This is the code that is run on the Arduino constantly when the system is running. So the previous code was only uploaded as tags were being written, whereas this is the constant reading, which is running on the Arduino Uno throughout the project. Again, it's very similar to the first. We're including the correct libraries, making an instance of the module, and defining how we're going to communicate over serial. I then begin the serial communication at this baud rate, define my LED pin, and wait for the serial transmission to begin. for the serial port to begin. Then blink the LED just to initialize it, and again set up this nano module. If there's any issue setting up this nano module, the user will then get this message. As often it's to do with no power to the module or other issues with wiring. So to look at what the setup nano does, it's the same as the previous. We begin the serial port, we begin at the right baud rate, we check that it is running correctly and that the port is open. Then we try and get the message coming from the nano module, and that might be an error code, and if so, to print some information about that, else continue on, and we try to get the version and check that it's the correct version, and this sort of begins communication with the module. If there's any issue with this, then it will produce this error code, which then this message will be printed to the serial for the user, and the nano will try to stop reading. If it's not that the module is continuously reading and not stopping, it might be that the baud rate is incorrect, so this kind of resets that and tries again, and then hopefully at that stage the connection will be good, and the tag protocol and antenna port can all be set, and it returns true. But if there's any issue there, false will be returned. So turn it back up. That's the setup nano method. Once the nano module has been set up, then you can set the region for the frequency to be read at, set the read power, and then prompt the user to begin so that the module can leave the initializing code and then move into just the loop code. So it waits just for some serial input to know when to start reading. Once it's started reading, it then starts checking to see if there's any data that's come in, constantly checking if there has been some data, to check is it just a normal keep alive response, in which case we just print scanning. If the response is that they've found a tag, then the LED is blinked on and stays on until the duration of this. Then we get the time that the tag has been found at and what the contents of that electronic product code is. So that'll come in as an array of bytes, or just as a number of bytes, which then is a character array. So we print the time and then print that array of characters, and also try and add it to try and decode that from this array of bytes into hex and print that just as a normal. Here it's just printed as a string. So the output here, it will be a timestamp followed by an array of bytes to show what is the content of the tag, and then that array of bytes translated into just a normal string, and then this LED will now be turned off, so that'll flash on and on every time a new tag is found. If there's any other errors shown, that this will be printed to the serial. So that just shows you an overview of what the code on the Uno is doing. It's just constantly reading for new tags and then printing the time it was found, the contents of the tag, and a more human readable version of that. This is just a brief look at the circuit playground code. This I'm not going to spend too much time on, as it's not incredibly important to the system. But it was based off these references at the top that used the both the Adafruit music examples and also this Chase NeoPixel code. So the idea of this is just that it plays some simple sounds and makes a strip of lights light up one after another in various colours. So including libraries at the beginning, defining the right pins to use for the NeoPixel, and defining the length of the NeoPixel strip, and then setting that up using this. And then I include pitches.h, and that is just a list of all of the different notes in standard music and the sound, their frequencies beside their names. So instead of having to remember each frequency, I can call a note that makes more musical sense. Again, these are via this link. That's the source of this code. So then I defined a number of melodies here and played with that. And the setup, I begin the NeoPixel strip, I begin the circuit playground, I play a hello sound, I delay and play another sound, and then when we go into the loop, I just fade through the rainbow. So when we're playing the sound, it giving them the melody and the durations of the notes. So each melody and then also the rests between it. So each of these notes then will have a number of time, and then each note is played for a certain duration, and then also given just a little pause between notes here. And then fade rainbow fades the LEDs within the NeoPixel strip between different colours, just kind of randomly changing them back and forth. And there's another method in here called call rainbow chase, which is a very it's a more structured way of changing the colours, whereas this is a more random way. And the actual chase is that the LEDs are changed one by one along the pixels of the string. So everything fades maybe from red, and then one pixel at a time to orange, to yellow, and so on, or to whatever colours that are shown here. This is the Python Flask code that runs on the Raspberry Pi. This runs a small website with the main functionality of the pizza blocks within it. It takes the previously set up serial data coming from the Arduino Uno, from the electronic product codes, from the tags that are registered by the system, and outputs them to a website with the functionality within it. So firstly, it's in Python. It imports the libraries that it needs for using Flask, visualizing the data, for reading from serial. From the serial port for using the threads and sleep, as well as for the decoding that serial data and finding regex functions within it. First we set up the website application using this, and then input the CSV file that has that sample data of nutritional data. That CSV file is here. It just quite simple, with some of these being real values and some being just dummy data. So it includes vitamins and minerals, allergens, and then the grams of fat, sugar, saturated salt, and the number of calories in each of these toppings. And beside each topping is an easier lookup. So instead of looking for margarita pizza slice, the system only has to look for slice or yellow pepper, as would come in from the serial port, which will be explained later. So this sample data is taken in and read to using the pandas library, and kept in this variable. All of the nutritional information is then initialized to 0, and then size of the pizza has been initialized here to 4, but later can be changed. These are also empty sets to include the vitamins and minerals within the pizza, the allergens within the pizza, and which toppings have been chosen by the user. Then we go to error handling. This catches errors around not having a favicon, and this is to later, when I have errors in the system, instead of completely crashing, it will show that error message rendered to an error.html page. This is the error HTML page, and it's using Flask to extend from this template page. So the template page is the main page that all HTML in the website extends on from. Here it just imports the bootstrap styling, inputs the style sheets needed, the fonts. It has a nav bar which is shown throughout the website, which shows the home, pizza ordering, about, and links to all of those pages within the website. There's a lot of bootstrap classes throughout that just do with styling. There's an introduction paragraph, and some font awesome icons are used as well. And then this allows the user to then input the block body here using this code. And then there's a footer and some scripts at the bottom, again for Bootstrap to use just for styling purposes. The error page is very simple. It just shows a message saying error thrown, and then allows the user to pass in allows the system to pass in the message here, as well as having a home button so that the user can then return home. The next thing that happens in the system is the serial port is opened on the Raspberry Pi so that it can communicate with the Arduino Uno. This serial port is defined, so it says where that port is, what the baud rate it should be communicating at is, and the timeout after which it should kill this attempt. Then the serial port writes a character, that's just an A character, but it could be any character, followed by a new line, which then allows the Arduino Uno to begin reading for tags. As was in the code, it just waits for this initial thing to begin reading, and then it reads this line so that the serial port doesn't have any data left in it, and then opens the serial port unless there is some sort of serial exception in this try catch or try except block. And then we go to the main functionality of the code. In this function, it gets the Arduino serial data. First you declare the variables, again writing a character so it begins to read tags, and then sleeps for a second, just to allow the serial data to catch up on itself. and then reads this so that the serial is essentially flushed. Then, while it's true, it tries to read a line of data and sees if there's any data being input. Once, if there is, it tries to decode this data and then prints it to the terminal, to the output. If there's some issue with the wiring, it'll print and raise that exception. If the data includes the electronic product code array, it will then take that information and try using this regex to decode and find just the relevant information within the electronic product code brackets, and then makes a list of the topping data by finding all of the examples of the EPC array. So within the data that's come in, so within this data there might be several tags, and it just tries to make a list of all of the tags that it finds, and that might be some being the same and some being different, and then prints that just for clarification on my end. Then it takes out all of the spaces that are put in that EPC array and tries to decode it for each in the list, and then adds it to the set. The benefit of using a set is that it will not continue to add new instances of the same information, as it'll only add unique information. So the same tag can't be added again and again. This means that each topping on the pizza is only included once. Then it just prints what's the content of the data and the contents of the set. Again, just for debug reasons. If there's any issues with decoding, it'll print a decoding error, and if there's any other exceptions, it'll print that exception for debugging purposes. Then there's the creation and maintenance of this background thread, so that this entire function to read tags is being constantly called by the serial thread, and it just continuously calls this method here. Now I'm going to skip over these as I'll come back to them presently, but here is the information about the routing within the website. So this sets a 404 page for if the error is a 404, and then this goes to this 404 page, which again extends the template page and just shows a small image and a sorry page does not exist message. Then there's also the index, the about, and the order, and it sets the root and then defines that and renders the template. In the about page, this again extends the template page, giving the about pizza box as the title and the body, has the about, and it has a number of pieces of just informational text, instructions, a list of instructions, an ordered list. Then we've got more information, and this links to the GitHub, also links to the previous student's project, which is related to this, and views where you can find the code, and also then has a link to raise issues on the GitHub for my project, and ends the block. So that's on the about page. And then the index page is the home page of the website. This again extends the template and it welcomes the user. There's some instructions and includes just some styling elements. Some font awesome icons are used and some quotes and links to other resources that are on the NHS website. And continue further links. Again, these are bootstrap styling elements. Again, the block is ended, but the main functionality being this button or this link, which as it uses a button, which then brings the user to the order. Just want to take a look at what happens when we order a pizza. So in the order pizza page, I add personal information. So a name, select an age from a drop-down box, select gender from the radio buttons, and the size of the pizza again from drop-down box, and then hopefully press submit on this order. Then this will come here as a post request, and if there's no serial data being registered and no toppings data has been set yet, the system will not allow you to order a pizza. It will not allow you to move on. If there is a toppings found, the form, we will request all the personal information from the form and redirect onto the simple plot method using all of these as parameters. Now in simple plot with these parameters we can render this template, go into that template, and it just has some basic information just showing kind of how that personalization function might look, showing all of the toppings that have been chosen, and then showing a really brief nutritional information on that. So this, to find this source of the image, goes to this method. That method is top list. So here we go to topping set and we get the nutrients for each of the slices of the pizza. We get the nutrients for depending on the size that's been set by that user. Then the nutrients for all of the toppings, and then we go back and we plot this bar chart of these nutrients and show that as an image, which is then sent back to the web page and displayed. So when we display this information, we get the slice nutrients. So let's go to get the slice nutrients. So this is to try and find out the initial nutrients just in the base of the pizza, depending on what size pizza they've set. So we're using these global variables so that the program can understand where everything is, or throughout when things are updated, the program can understand. So this goes to the nutrients data, which is that pandas data frame that's already been set up. It looks up the slice, which then gives the base information for a slice. So if we go back here, this is slice, that's that lookup, margherita pizza slice, and then gives information around what's contained within that slice, just a single slice. Then it updates the nutrients based on the values for that lookup. So it finds the row, so that'll be just this row here, and then it finds the calories by finding a certain value. So it goes to calories and then finds that value and times it by the size of the pizza. So this means that for each, so if the pizza size is 4, that's 4 slices in the pizza, and you need to times the calories in that one slice by 4 for the size of the pizza, and that gives you the calories, and that's updated for each of the nutrients in turn. And then we're also including the vitamins and minerals. So this is just to format the strings so that we ensure that it's each of the vitamins that are listed, A, B, or just A, are all included as a separate element in the list, and each of those elements in the list is added to the vitamins and minerals. Again, this is a set so that each vitamin or mineral included is not added multiple times. So if there's vitamin A in the pizza base, we want that only to be included once and not multiple times. Then allergens, again, if there's dairy, we only want that to be once, added once. So now we've got the initial nutrients of just the whole pizza base without any toppings. So this is just the slices dependent on the size given by the user in the previous. And calculate nutrients. So again, we're using these global variables, so that if the calories are changed within this method, they're changed throughout the system, throughout the program. So for each topping within the set, which again only holds unique toppings, we find the row with that topping in it by going to the lookup. So it'll then find red onion, for example, and which is stored as this because there was an error. So then red onion, and have all the information here. And each of those are going to be updated. Each of these totals of grams of fat and sugar and salt. And then it will also find the vitamin and allergen in that topping. So, for example, in red onion, if the vitamin doesn't already exist within the vitamins and minerals toppings, and it's not empty, we'll then go through and try and again add it to that list. And again, we do the same thing with the allergen, and we're just adding unique allergens to the list. So over time, we're building up all of the allergens within the pizza, but not repeating ourselves. And if there's any issues finding any of this information, it's caught by this exception and then printed. So we'll go back again. So we've now got all the nutrients just from the base of the pizza, then all of the nutrients from each of the toppings of the pizza. So hopefully now we have all the correct nutrients, all the values. So we now want to work out what that looks like in a chart. So if I go to plot bar chart, so we put all of that information into a new pandas data frame. So this is it, with the column names being calorie, fat, saturated, sugar and salt. And then we can plot this as a bar chart with the summary and the labels. So this now returns a plot which should show just the total nutrients within this pizza. Now at any stage, if there's issues with finding anything in topping set, or if there's any other exceptions, these error messages are caught and then redirected to the error page. So these error messages are then displayed on this URL. To remind you, it's just a simple page. This final piece of code I've used, it's coming from Stack Overflow, but it's to prevent the image from caching. So this is so that when I try and update my image by pressing on this refresh page, it shouldn't shouldn't have any issues trying to cache that image. So as I add new toppings, I shouldn't have a display which is outdated. It'll continue to update with me because it has not cached. And then finally, we run the app. So this is just a final statement that allows the Flask app to run and at this host and port. So to recap, we import all the libraries. We set up the website. We take the input from the nutritional data sample file, which is a simple file just including the topping and the nutritional information, including the vitamins and minerals within each topping and the allergens within each topping. We initialize these variables about the nutritional content and the size of the pizza, as well as the unique sets for containing both vitamins, minerals, allergens, and the toppings chosen by the user. We handle errors by setting up some routing for that. Open the serial port so that there's communication between the Raspberry Pi and the Arduino Uno. And then we send some initial information so that the Arduino Uno then begins to read. Again, we're finding any errors and catching them. Throughout, there's a thread which calls this method get Arduino, and this is a constantly running background thread, so that if there's any input from the serial, this is always going to be read, even as the user is also using the website. It's just a background thread, and we declare the variables, making sure that these topping set and serial data are indeed global. We write information to the serial. This is again just to initialize the Arduino so that it begins reading. Then, while true, so in this loop, we just continue to read data from the serial, and if this data exists, try and decode it, print it. If there's any issue, we raise that exception. If EPC is in data, which is electronic product code, which is just to locate if the data includes information about the toppings, or if it's just an error message. So if the EPC is in data, then serial data is set to true. Then we try and find the relevant parts of information coming from the serial data. So that's just the byte array, which includes the information about the cereal, about the topping. So this regex will find the information just between square brackets, which is a number of hex values. We find all of these EPC codes within the data that's come in from the serial port, and we make it a list. And then for each item in this list, we decode so that it's no longer hex. And so first it's replacing all of the spaces and just taking those out. So any spaces between pairs are removed, and then we decode it so the data is now in hex, and now it's decoded again, and this brings it to ASCII, and then it's added to the topping set. So each unique topping is added to the set. This means that if the serial data reads the same tag multiple times, it's only added to the set once. So it's not, so a topping isn't constantly added to the list, making the list longer and longer and longer. And there's several print statements throughout, which are just to help understand what's going on for me as a coder. The except blocks will raise any exceptions, retrieving or decoding the data. So again, that's constantly happening. This is just constantly reading, looking for the electronic product codes, trying to then read them, trying to make sense of them into ASCII strings, and then trying to add them each unique topping. So hopefully we're in this function, we're just constantly getting a list of all of the toppings being added by the user. This function gets the nutrients of just one slice of pizza with no topping on it. We're using global variables so that each variable, when it's updated within this method, is also updated elsewhere in the program. This looks for the nutrients data which is found in sample CSV, and for each row it finds that. So for a slice it'll find 108 calories. It'll times that by the size of the pizza. So if it's 4 slices, it'll times 108 by 4, and that will be the new calories, which are added then to. And we do that for each of the nutrients. So this method will try and get all of the nutrients for that one slice, and then all of the vitamins and minerals and all of the allergens for each of those slices. We'll then also try and we have a method to try and calculate each of the nutrients in each of the specific toppings. So for each topping that is added by the user, each of these toppings will be then, their nutrients will be calculated and added to those global variables. And including the vitamins and minerals within them and the allergens within each topping, with any exception, again, being printed. This function will plot a bar chart of the nutrients, so it's called after these two, so that now, once we have our final calories, fat, saturated, sugar and salt, we can add them into this this new data frame in pandas, and with the columns labelled, and then just display them within a bar chart and plot it using matplotlib, and label both the X and the Y. There's routing. This allows the user to navigate within the website. So when we go to each route, these various HTML templates are displayed. So beneath the routing, we have just the main functionality for how to order. There's the post and get methods. If it is a post method, then it will start to try and find if there is any serial data, and then request the information from the page on the form. So as the user continues to add their personal data, such as how many slices of pizza they'd want, that's seen in the request form. So it just gets these various different parameters and sets them to something else and sends all of these through to the next URL. And this adds all of the toppings together into one single string, just so that it's easier to display. And then finally, this was just a piece of a test method, which was useful to keep in. There's no particular reason to take out, and that just shows you can pass in a username, and it will just show the toppings and the username. but then obviously I extended on from that into what the final piece became. Then here's the routing to try and get to the plot. So this is how I send all of that information through and render that in the template. Toppings list is the method called by the simple plot, by the image on that page, and this is the one that calls all of those previous methods to get the nutrients and get the nutrients from the slice and in the toppings and plot this bar chart, show this file, and some error catching, and finally this anti-caching header so that the image doesn't remain cached, and then finally just running the website. So I hope that's a clear enough explanation of how the code works throughout the entire system. To have a better idea possibly of what this looks like when it's in action, then I'll now show the demo.